All right, welcome everyone. We are C++ the basics today, and for today's session, it's kind of like an impromptu programming workshop that we're doing, during reading week for students and everyone else that wants to join. So I've kind of extended the welcome to different people in and outside of our organization. So this is being streamed on YouTube, it's on Zoom, and we also have it on Discord for some of our students. So welcome. So I wanted to start with, of course, me. This is me. You know me. Most people, I think, on the channel, I think right now, know who I am because I'm probably your professor. But if you don't know me, this is me. I've been kind of programming for a while, and I wanted to talk about why I wanted to do this thing. And so, why am I doing this? And I think this is the main thing, which is I love to code. And I always think about solving puzzles with code. When I look at code, I see it as a puzzle in many ways. And I'm thinking about, if I was looking at that code, how could I make it better? That's the first thing I think about in my mind. And lately, I've been really seeing students struggling to understand just the basics, like, how to put things together, especially in C++. So I wanted to really help. And that's why we're doing this thing in our reading week. So we got a lot of stuff to cover. Now, it looks like a big list, and it is. Normally, this kind of thing, if I was teaching it in during regular semester, or if it was Wallace or my friend Rich on Zoom or anybody else, we would probably go way slower. Okay, so this is, like I said earlier, is a speed run. Okay, we're doing this really, really quickly. But I wanted to talk about this so that way it might, click somewhere in your thoughts and the way you're coding. And that's why I invited you all to be here today. So lots of stuff. And I want to start with an intro to C++. What the heck is it? Why do we use it? And, and that kind of thing. So really, when we think about the basics, I always think about what the heck is C++, right? So it's like, it's a general purpose programming language, and it's different than C Sharp. Excuse me, I'm losing my voice today. One thing that it has is something called a standard library, which is similar to C Sharp, but it's a much lower level language. Okay, so by the way, these slides, if you're interested in having them, we'll post them later on Discord, and I can always post them later on for anyone else who wants them. So what about if you're a C Sharp developer? Because I think this is the audience that we have here today. You guys have done Unity. You guys have been using Unity, as an example, and Unity uses C Sharp as scripting. Other friends of mine who are online on Zoom, C Sharp is probably their very comfortable language. So I wanted to talk about C++ from a C Sharp developer perspective. So one of the things is that C Sharp uses garbage collection a lot of times, and well, all the time actually. And for C++, it requires manual memory management, and that's kind of the one thing I put here to understand, which makes it kind of more complex to navigate a bit for students when they first start to learn it. The other one is it's more efficient, and I put in a couple places where it's more efficient, which is C Sharp. When it compiles, it goes to something called intermediate language, whereas C++ directly compiles to machine code. So that's the other thing that's different. And then C Sharp manages a lot of stuff for you, a lot of the stuff in the background. So the things that you don't have to think about, it's kind of like a black box when it comes to the way it does things, whereas C++, you have full control. When I think about this, it's positive and negative. And the positive is it's like I'm flying a plane. If I was going to fly a plane with C Sharp, if it was a C Sharp plane, then I'd be flying it with an actual wheel, and I could probably change my pitch and roll and all that stuff nice and easy. But with C++, I always look at it and it's like, instead of having a wheel, it's a bunch of dials, switches, and buttons. That's what it looks like, and it's a lot of control. But turning the plane in C++ would take a lot more than turning the plane in C Sharp sometimes. Okay, and that's why I want you to think about it, especially when it comes to managing how the plane is using its energy. If I was going to say where energy equals to memory management. Okay. So one thing that C Sharp has, which if you've done Unity or if you've been programming in C Sharp for a long time, it has an object-oriented paradigm, which means it's object-oriented from the ground up, just like Java is, as an example. Whereas C++ is multi-paradigm, which means there is no class to start with. It starts with a function, so it can be procedural, it can be object-oriented. That's the C++ side, plus. Functional. It really depends on what kind of programming you want to do, right? The other thing that's different about C++ than in C Sharp is it's platform independent, which means it doesn't have to be on Windows C Sharp, a lot of times it's Windows. Could you do it on other systems? Yes, you can with Visual Studio Code. But the most comfortable way to program in C Sharp, in my experience, is with Visual Studio, right? So it's, again, it's more Windows related or Windows, kind of targeted. Game development, C Sharp is great with Unity, and Unity, we use it for a lot of indie development. C++ is, we've known this semester, is all with Unreal Engine, and we'll talk about why. These are all the reasons. It's more performant. So if I'm not programming games, what is it really useful for? And for me, it's if you're going to build an operating system, C++. Embedded systems like automotive software, medical devices, financial and trading software, web browsers, all kinds of stuff that you see here in the list, 3D modeling software, AI, at least the back end, the core stuff in AI, TensorFlow, and those kind of things, all built with C++. Extended reality, SDKs, for example, SteamVR and Oculus SDK, all built with C++. Why? Super efficient. All right, that's why it's for. But also millions of lines of code for all this stuff. So tools to program, there are more than this. I'm showing you Visual Studio and Visual Studio Code. JetBrains is proprietary. Again, we have access to Visual Studio and Visual Studio Code. If you have a Mac, you have access to Xcode. And if I was going to say which one I prefer, of course, is Visual Studio for C++. Why? It's got a lot of the tooling there for you. So again, if you're following along today, please pull up your Visual Studio if you have it. And then if you want to follow along, and then you can kind of do what I'm doing. So that's the first part. And let's do that now. So instead of me, watching and follow along with PowerPoints. PowerPoints are going to guide us. We're going to use them as a frame, but we're not necessarily going to, kind of read all that stuff. I just wanted to introduce it to you. So here I am pulling up Visual Studio 2022. And again, this is like I said before, a speed run. So we're going to try and do this so that we get the basics out and then get you guys to, ask some questions. Again, this is a 3-hour thing. So we're going to take some breaks. I'm going to take a time, and we're going to make sure we get through all the stuff. So if I introduce something and then you want me to stop me. Most of the people that are here are on the stage, or if you're not on the stage, you can always, again, send something in the chat. I have a couple people here that can, kind of moderate things. I've got Wallace here and other people, and so you can ask me those questions. All right, so I want to create a new project here. I'm in Visual Studio 2022. And I just pulled it up. Again, the only requirement for Visual Studio to work with C++ is you have to have those modules in there. So my assumption I'm making, and maybe this is the wrong assumption, is that when you've loaded Visual Studio 2022, you have the ability to add those modules. And if you don't, I don't have this in the PowerPoint, you can always go to your Visual Studio installer. So I'm just going to bring this up for those people who are doing this from home or who have Visual Studio available to them outside of our college. So Visual Studio Installer allows you to modify your installation. And the installation that you would need is the C++ modules. So again, there's different ways, but one of the modules that you want here is desktop development with C++. That's the one you want to turn on. Now, if you're doing that right now, you're probably going to have to do this later on, right? If you need to turn this on, if it's not on already for you. Because if it's not, this will take some time to kick off and download. Unfortunately, Visual Studio is slow to update. I wish it was faster, but it's not. All right, so I already have it, so I'm not going to do this. Instead, I'm going to start off with a brand new project, and we're going to click on Create New Project. So let's do that here. When you first start off, it might take you to this, which shows you all languages, right? Now, if you have a bunch of stuff installed like I do, then you're going to see a bunch of different things here, things that aren't related to what we're doing today. What we want to do is we want to click all languages and click on C++, select C++, okay? And there's a couple of options here to start with C++. You can do an empty project, start from scratch, or we can start off with a console app. And I want to start with this one because it's going to show us a lot of things that we can learn just from the console app right here. So I'm going to click on this. And then I'm going to click Next. Now your location, like where are you going to put this stuff? This is your configuration of your project. And this is another reason why I like C++ and Visual Studio. Visual Studio does all the heavy lifting for you in terms of how it's going to compile, how it's going to link everything together. If you're doing this with VS Code or some other kind of software, especially if it's an editor, you'd have to do all the linking and the compiling yourself, which to me is, not optimal, especially when it comes to learning. So here I'm just going to call this like first program, which is kind of what I put in the PowerPoint slides. There's my first program. Okay. And we're going to add some solutions in here throughout the time that we're together, but we'll start with first program. So that might nice and easy. And then we're going to click create. So again, you can see that my location is in my downloads folder. You can put it somewhere that's safe for you. I don't recommend it putting in anywhere that is your OneDrive. If you're using OneDrive, OneDrive is pretty destructive when it comes to how it puts things up online. So I recommend not using OneDrive for the folder that you're targeting to put this in. Okay, let's click create. So now Visual Studio is going to do its magic, and it's created our application. A couple things, if you never used Visual Studio before, I got to talk about that too. My bar, I'm using a fat kind of like scroll bar. You don't have to do this. This is just an option. And on the right, you can see that I have my Solution Explorer. And inside of my filter, now one thing that's different about C# and C++ is in C++, these are filters. They're not folders, right? So if I open this up, it looks like a folder, but it's not. Okay, it's just here inside of our Visual Studio view. Okay, so this is a filter. You can make as many filters as you want, and it won't impact your operating system view, whatever it looks like on the operating system side. Here you notice that it's called first program. It kind of created something called firstprogram.cpp. CPP is the extension for C++ as an example, and this is just one file that we're looking at today. So one thing that we're not going to do today is talk about .h files, header files. We don't need to do that because header files are really used for object-oriented programming and other things. Could I make it in a header file? Yes, I could, but I think the simplest way to proceed today is just do this, okay? So let's take a look at this if we were to look at the code. So one thing I've done in the PowerPoint when I share it for you is I've skipped through this process, but I really want to talk about what it gives you. And the first thing is it gives you comments, and there's a preprocessor command, which is an include. Then there's the main function, which is our entry point into our application, followed by a statement of code, okay? And it must end with a semicolon. And the reason why is because C++, it's not C, but it's a C-influenced language, and all C-influenced languages use a couple of similar things in their syntax. One is there's semicolon, and then there's curly braces, and this kind of stuff that we're going to be talking about today. So if we're going to kind of deconstruct our code a little bit, which is what I do in the next several slides, I want to talk about what all these things are. So first, let's see if we can run it. I mean, the first thing I'd like to do whenever I get boilerplate like this, and I say boilerplate because this is kind of something that the system generated for me. I didn't write any of this. And if I click on this little button up here, which is my local debugger, then it should run a little window. In a window, it should run my code. And you can see here I've got hello world. Yay. It's really exciting. Right. So hopefully you guys got to this point. Did anyone else, is anyone not able to do this? And if you can't, it's usually because you're not set up properly in Visual Studio, which is totally fine. So hello world is like the classic thing. I mean, it's actually incorrect the way it's been written. And so let's correct it. Usually what I like to do is change hello world to hello, comma, world. And that is the actual correct way of doing it. Let's save that. So if I save that and rerun it, you can see now that we can do this kind of stuff. And I want to talk about the structure that we have in our C++ application here. So again, we have comments at the top here, and their comments are, so the forward slashes here, as an example, are just examples of single line comments. That's what they are. Well, we can write comments in different ways. So let's just get rid of this. This is just explanation here at the bottom about what you could do to debug and run your code. So Control F5 is also another way of doing it. So if I was going to erase this stuff and press Control F5, then I can also run my code this way. Okay, and you can see that it runs pretty much the same way that it did before. So that's the one thing that you're going to see here. And I'm just going to zoom in here so you guys can see this easier. So this is a single line of code, but what if I wanted to use multi-line comments? And you're going to see multi-line comments are the same as in some other languages, where you can actually add whatever comment you want here. So here is multi-line Amit. And you can see my uh, Copilot's kicking in, and it's trying to help me because I'm running with Copilot on the right-hand side here, way up here. So what about this part? Include IO stream. Does anyone know what this means? I kind of put it in the PowerPoint, which I'll show you in a second, but anybody, what does include kind of statement mean? What do you think it means? Again, this is a workshop. It's not just me, it's not a lecture. So if you want to kind of kick in there. So Gavin says IOStream is a standard library. Correct, right? That is absolutely correct. And are you asking me or someone else? Oh, Gavin, right. So the include statement, whenever we have an include statement inside of a file, what it's actually doing, and it's different if you're a C# person, a lot of times we use a using statement. And a using statement is very similar to include. What we're doing here is we're injecting the library and making it available inside of this file. IOStream, by the way, is quite large, right? So we only want to include libraries when we absolutely need them. And we need it because we're trying to do this, which is cout, okay? And we'll talk about what that cout is in a second. But that's the first line of code. This first line is like, hey, let's get a library and inject it into our code. And you're going to be like, wait, this is Tom, this is like C++ the basics. Do I really need to have this library? And the answer is, well, without it, then you can't do anything you can't output anything to the console. And if you look to see what this is, it says actually console out. That's what cout stands for. Okay, so that's the first thing. The other thing is whether you know it or not, you're using a function right away. And function main is the first function that you would see here. Every program in C++, unless it's running somewhere else, like for example in Unreal Engine, where it's hosted as a framework, there must be a main function for it to run from. Main, in effect, is your entry point into the C++ world. Without main, you can't run anything. Okay, that's the way it is in C++, typically. So that is the one thing that you're going to see here in this thing. We also have this standard cout, and then you have this delimiter, : : and some people might be like, wait, so this is, if I hover over, it says namespace standard, right? That's what this is. And then some people might say, well, wait, can't you just use a using statement, Tom? And if I use using namespace standard, can I do this? And then if I did this, could I just like get rid of this and just do a cout, right? And the problem with doing this, and by the way, you might see some examples online where they suggest, hey, you can use, using, and then put this up. It's very specific to Microsoft's Windows environment, okay? Using doesn't necessarily work everywhere. And so that's why I highly recommend when you're doing C++ to not do this, right? Even if the book tells you to do it. If you're looking at a book or, watching some kind of video, don't do this at all. And instead, notice that it just turned into a problem right now. When I did that, put in that standard library with a delimiter. So standard is the standard template library. That's what we're accessing. And it says namespace standard, but actually it's a standard template library that we're accessing. And we're saying, hey, go into to the standard template library and use IOStream. Okay. So that is, so it's kind of like a Python import, I would say. It's kind of like that. But instead of it being a Python import, it's installing it in your file. And so what happens is if we were going to build this thing, the application gets fatter because what happens is we have all this stuff in there, right? So that's something that you're going to see a lot when it comes to including things. When we do our second workshop, which I'm not sure will happen this week, probably next week, when we talk, or the week after, I'll probably do another one during the middle of the week sometime, and I'll try and figure out what time works for everybody. When we talk about OOP, you'll see that including something like this inside of a header file or a class is actually naive. It's bad to do, right? And the reason why we talk about it as naive or bad to do is because now everything that accesses that file also gets that installed, and you may not need that library to be kind of copied to all the the entire application. Only maybe some files need it, but not all of them, right? So this is where, again, remember the differences between C++ and C Sharp. C Sharp lets you manage, kind of manages everything for you, and C++, you're managing it all yourself, right? So this is what but we do need this right now, because without it, we don't have C out. So again, if I was to take this away, right? And then you're going to see that C out, it just shows us like, hey, I don't know, standard namespace by itself without an include has no idea how to use C out or our output. Okay, so you do need that include back. Next, we have these funny marks right here, these two less than signs, right? And when we look at the double left-hand signs or less than signs, I want you to think about it as a string, right? So imagine if I have all this data and I want to take that data and send it somewhere, then this is kind of our stream operator. That's what it is. And there's two stream operators. There's the less than operator and the greater than operator. So the less than operator, this stream operator, it takes whatever's on the right-hand side, it sends it to the left-hand side. So the right-hand side goes to the left-hand side. And if I was going to annotate this a little bit just to make sure you can see it. So all this stuff here, right, it kind of takes it and puts it here. So it sends all of this to the console, because that's what this stands for. Console output is what this is, right? So you have this part. The other part that you have is this right here. So there's two parts, right, inside of your string here. You clearly see that this is a string literal, right? And you've got the string piece, characters in a string, as well as this part. And these are your escape characters. And your escape characters are \n. \n is an escape sequence that means new line. Okay, that's what it means. I could have written this differently, and we're going to do that in a second, right? So let's try this out. I'm just going to clear all my drawings here. So if I wanted to write this, is another way to write the same thing. I can remove the \n, right? And I can also stream a standard end line, right? And the standard end line does the exact same thing as our \n. I'm getting an underline, which is like, hey, insert new line and flush the stream. Do not use a standard end line with streams, use \n instead. It's telling you that, yeah, there's a better way of doing this, is what I'm getting. But you could do this if you want it to be explicit. And sometimes you need to do this if you want certain things. Now, remember, we've said this a lot of times. If you know me and if you spend time in my classes or anything like that, then you know that things that are done in a language, they're there for a reason. They're usually there to solve some kind of problem. That's what it is, right? So this is just a language construct. That's what this thing is, that allows you to do things in different ways. Okay, so let's try this out. Let's see if I was going to run this again. And it should just run the exact same way. You can see hello world, no problem. If I press Control F5, also the same way, it'll run hello world. It runs a little faster with Control F5, right? So let me explain why. All right, so again, if you look at build, you can see that you can, on the top here, you can build my solution, right, as an example. So that's everything in my solution. My solution right now only has one project, which is my first program. That's what it's called. So if I go build, that builds the entire solution. That's my project, maybe other projects at the same time. If I just want to build my project, I can just go build first program. So that's Shift F6, and that will build my project, right? And if I want to run and build, then this is where I'm doing it. Like right now, you can see that my configuration is set for debug, and later on, not in this little workshop and maybe in other workshops, we'll talk about how you can change your configuration to a release type configuration. And why would I want to? One of the reasons why in the future we might change to release is because it'll actually run faster, okay? But it'll give us less debugging information. So for now, debug is probably the right thing we want to use. Also the target, this is the target platform. Right now it's our solution platform is x64. You can see that you can target other solutions platforms as well. All right, so those are the things that you can do here. Under local Windows debugger, there's other options here that you can choose, but local Windows debugger is the right thing for us to use. There are other things that you can do so you can debug your project in different ways. Okay, so that is kind of just wanted to go through Visual Studio's options up here at the top. So Control F5. If I go to project, as an example, there's some other options here in the project as well. And we're not going to handle them today, but I want to talk about them really briefly. And one of them is this first program properties, right? So Connor may have taken you through this. If you've worked with Connor before in any kind of lighting, rendering, anything like that, you may want to configure your project differently right here. If I click on this, it'll bring up my configuration. I only want to talk about it briefly because, again, this is a speed run. We don't have a lot of time for this. But a couple things that might make your application in Visual Studio work different than mine, okay, is this. Okay, so let me talk about this. One, Windows SDK version is targeting Windows 10 latest. Okay, that's what it says. You can see that there's other options that I can target here as well. Okay, and the other one is the platform toolset that I'm using is 143. This may be different for you, by the way, these options. The other thing is the C++ language standard. One thing that happens with C Sharp by default, pulls in the latest language if you want to use it. There's other more advanced features that sometimes are turned off in C Sharp as well. But here on C++, you can choose the standard library that you want to use. And you can see here that we support 14, 17, and 20. Those are the three standards that have been out there over the last little while. Okay, I think C Sharp is at .NET 13 and C Sharp 7 or 8, I think it is. I don't know. Correct me if I'm wrong. But anyways, that's what it is right now. And you can see this is the configuration that you're going to see here. Okay. Again, we don't have to monkey with this, but if I was going to do things manually, I would do it here. I can actually modify my manually linking and compiling and everything in here. Let's click cancel, please. I don't want to modify anything there by accident. So the configuration's been set. You can press the button, or you can press Control F5 and you can launch your program. And we have our standard stream, this standard stream operator that takes the string and sends it into our console. And we're using standard all the time as a delimiter because we don't want to use using. We don't want to do that. Okay. Are we good with this? Hopefully you are. I'm going pretty slow. Multi-line comments are pretty cool. Comments in general, I know that some people might say that, comments are bad, right? Comments are, you don't need to use comments. Comments clutter your code and that kind of thing. I disagree. I think comments are 100% necessary for what you're doing. And I think that it's very, very important that, you comment your code well, but you don't necessarily have to, over comment. Like, for example, a bad comment would be like, this outputs hello world to the console. That is a very bad comment. And the reason why it's really bad is because you can read it right here, right? Unless you didn't know what cout was, like if you're a beginner and you wanted to know what this is, right? And you didn't know what this is, that's fine. But 100%, I recommend using comments that are better than this. So what's a comment, and I'm just going to look here at Discord for a second. What's a comment that might be better than this, for this line? I know it's not really complex, guys, and I'm sorry I'm going so slow, but tell me what a comment would be if you were going to comment this code. What would it be? Anyone have a suggestion? And the reason why I'm asking, yeah.
If I was commenting this code specifically,
yep.
I would just cut out pretty much everything past output.
Mm-hmm.
I would just, or I would just say this output, this output.
This outputs?
I would just put that outputs to console. I would keep it nice and short. Just outputs to console.
Okay.
That's it. Because if you read it, like you obviously know what it's outputting. If you're saying this outputs to console, but
What about if I said using the standard, console output string? How about that? Is that good? Is that bad? Like, do I need this? What do you think, Jesse? You say it's too much, right? So
too much for a beginner, it's not a bad decision, but in general, I would say it's far too much.
So to me, you know what? Like you said, for beginners, if you're learning and if you want to remember what this does, then that's okay, right? You can put that in. But I think if I saw this in an assignment, I'd be like, okay, guys, I don't need to know, stuff that we already know, which is what this thing does. Okay, how about this? What if I comment my function here? If I say something like, this is the entry point to the application. How about if I did that? Is that bad or good?
Bad.
Bad? Yeah. So again,
That's the main function.
If it's the main function, we know that this is the, what it does. So commenting something like this, again, unless if it helps you, great, right? But this is something you'd remove pretty quickly, because if I was to come back to this 5 years later, I'd be like, yeah, what do I need this comment for? It's useless, right? So I don't recommend you put this in there unless you're just learning, okay? So again, there's not much meat to our code right now. So, for me, it's good to kind of put this in there. It's good to, if you don't understand what it does, you know, what about putting comments, kind of putting comments in different places? Like, for example, I put it above. That's my style. But what about putting comments over here? This is, a, a
That's how I
comment,
do it.
right? Like this. What is this bad? Good? What do you recommend? Do you guys like this one, this commenting style?
I think it keeps me in check. It's like I don't have a rubber duck, but I do like my own commenting to keep myself
So
from going crazy.
Griffin says
And then
you can't comment multiple lines though. You can't add multiple things here. You can only do one thing, right? So, so I kind of like this, but I kind of don't. And it's the same reason why I don't put my curly braces when I'm doing my coding style. We're talking coding style for a second. I don't put my curly braces like this. Okay, some people really like this style, of curly braces, and that kind of thing. And I'm talking about really interesting syntax because, some people would like this a lot more than what I do, which is this. I prefer this, where my curly braces are on top of each other, right? And I'm talking about curly braces now because we're going to see them later. But who does this? Who likes to do this part more? And who favors this structure? Anybody? I'll tell you why I don't, okay? I'll tell you why I don't favor this style. Because if I ever want to change main, or if I ever wanted to change the function, right? Or if I wanted to comment it out, then, if I wanted to change the function name, which we'll get to later on, I would also comment out my curly brace, which would break it, okay? So to me, that's where I have a problem. So comments on the side, I don't favor this, okay? I don't favor this style, okay? I actually like the comments where I'm putting the comment on the top of whatever I'm doing. So if I'm going to comment something, it's going to go here, okay? Multi-line comments are great if you want to define things like, if you're using something like Javadoc equivalent, this is kind of the equivalent to using a more complex commenting style, where I want to talk about what this is. Here would be your description when it comes to comments, right? So this is the function of the program. That's pretty good. And then anything that it returns or takes in, we're going to see this style when we get to functions later on. I like using this style a lot. And the reason for it is because when you use this style and, you implement a function later on, if you hover over that function name, it'll tell you what it does, right? So that's why I'm suggesting that you always use this style. And we'll come back to this when we hit functions later on today. All right, so for now, very simple program. And, again, I'm going to go with this recommendation of putting the \n in here, right? Only because you don't need this if you don't have to, okay? One more thing. A lot of times you can get away without using curly braces. And I highly recommend, we're going to get to that when we do if statements and decision making. I highly recommend against not using curly braces at all times. I know some people, it's controversial. Some people love to skip the curly brace because they skip lines of code and all that kind of stuff, but not for me. All right, so we've graduated from this. This is good. I'm happy about that you guys understand this. Again, C out is the console out. This is the input stream or the stream that goes this way. What about getting input? Okay, that's another thing that we want to think about as well. I want to get input and I want to put it somewhere. Well, in order for us to do that, we need to use something called variables. I want us to direct you guys back to our little PowerPoint, covered all this stuff, right? And again, I'll post the PowerPoint along with everything else later on. So we talked about comments. So variables, interesting. So to me, whenever I think about variables, I always think about them as a named location memory. That's what it kind of looks like for me, right? So it's a named location memory. I want to store data somehow. And things that you should know about variables is they have these three things. Some kind of type. They have to have a name, sometimes also called an identifier, and a value. All right, there's some kind of value that you're going to store in this variable. Again, we're talking about value types right now, okay? Talk about reference types another day. Today, it's all around value types, okay? So again, variables are declared. They're created somehow. And like this, So where the type is first, followed by the variable name and a semicolon. Again, without a semicolon, you don't have a statement. A proper statement of code includes all this. If I go back to my code, this is a statement of code, the entire thing with a semicolon. Think about a semicolon as like the end of a sentence. Without this, it's not proper. Okay, it doesn't, the sentence doesn't make any sense without proper syntax, proper punctuation. And this punctuation mark or semicolon is like required. And for most languages, other than Python, and I think it's Golang and some other languages like that, we always need a semicolon. Swift too. Sorry, Swift. So, so that's the first thing. So we declare something first, and then we assign a value to it. So we have declaration step, and we have an assignment step. The assignment step uses the equals operator. Notice how I said equals operator, because that's what it is. It's something that needs to be done. This equals operator doesn't mean that it's equivalent to. This means I take the value that I have on my right side and I assign it to the variable that I have on my left side. Okay, that's what it does. And when we have something like this, something called an expression. All right, so this is an expression or a statement. Some people call these things the same things. But I want to talk about this with you just so you understand we're using the same languages here. All right, so let's go back to this then, and I want to make this more interesting, and I want to keep track of my my player's score. Okay, let's suppose this is the thing for today. So I have my player score, and I want to talk about variable naming conventions for a second. Let's talk about this. So I want to make it an integer, right? And I want to call this player score. How about that? Is that a good name? Just talking. I'm just saying. If you're going to look at this, if I had this. I mean, then I'd have to put in a comment like, this is my player score, right? So I have to do that, right? So this is terrible, right? I see this sometimes in people's code, and they think it's being smart or short, and it looks like, to me, you want to kind of do this and everything else because you want to save space, or maybe you want to be cute, or whatever you're doing. Please don't do this. This doesn't make any sense for me. And it shouldn't make any sense for you. Like, imagine 5 years from now, you're talking about the player score, and you have this. You'd be like, huh, what the heck is that? Like, player score. So there's a couple of ways you can name this. You can call this player score, and this is called camel case. That's what this is, player score. And this is just a declaration, so there's no initialization. That's the other step we have to make, right? But player score, that's one way of doing it. The other way of doing it is this, player underscore score, right? That's another way of naming it. So these are all different names. I can do int player score, I can do player score, and I can do int player score, right? And I could also do an int underscore player score, right? And I can also do int m underscore eventually, player score. Lots of ways of naming player score, right? So this is really, really important to understand different ways of doing this. And you can see that my C++, I'll talk about the M in a second, but C++ prefers this, but gives me marks here telling me that something's wrong with these ones, right? So they're saying, hey, these ones maybe not so good, but this one is an okay one. This one, it says that it's like not good. Local variable is not initialized is what it says. None of these are initialized. But this one didn't even complain. That's one thing that that we had there. By the way, these are all valid names, right? And we usually use the M to signify member variable. Now, again, we're not doing OOP, so we can get rid of these two. Underscore usually denotes private. That's a private variable a lot of times. So a member variable that's private. This is very common when we look at C++ applications, right? Very, very common. So for now, let's get rid of this because we don't have private and public. We don't have OOP right now. We just have these. So let's choose from these three. Which one of these three do you think are kind of the best way to kind of put out a player score? What's your convention? Number 2. Okay, so some people voted for number 2, player score, right? Some people like number 3, right? Well, here's something. If you're using Unreal Engine, okay, Unreal Engine prefers prefers this. Okay, that's what it likes a lot. Player score. That's what it likes. It doesn't like the lowercase at all, actually. If you're for an average, if you're kind of programming, the average programmer that I know likes to use this. Okay, and some people like to use this, but I don't prefer this because I mean it's an extra character that you don't need. And if you're solving a problem, fine. Like let's say for example you already have a player score and you want to make a temporary variable just because you're testing something. This is okay, but I would recommend against this one. Okay, so that's just me. So this is like I would not use this one. Okay, so it kind of goes between these two. Oop, look at that. So one of them is this is camel case, right? So this is camel case. That's what it's called. And camel case is definitely preferred in C++, 100%. That's what this comment just said, and it's true, right? And this is called upper camel case. Camel case, right? Also called Pascal case in some places. Okay, so that's what it's also called, right? So upper camel case preferred with Unreal Engine. So when we are together and we're kind of programming in Unreal Engine, you'll see me use upper camel case more often than not. Okay, not because I want to do that. Also in C#. C# prefers in many cases upper camel case, especially for its function names, methods, compared to lowercase or upper, just regular camel case. So camel case is also preferred in Java as well. So if you're programming in Java, that language, camel case is what you're going to see a lot there in Java and even in Kotlin, right? So if you're a person who's programming in those two languages, Java or Kotlin, it's camel case. And in many places, camel case is the preferred way. But for today, we're going to be using camel case, player score, not upper camel case. So I'm going to use this one. So I've eliminated two. And this is us declaring the variable, right? So we're going to say this is variable declaration. That's what we're doing here. So we're declaring the variable, but we're at declaration. There we go, Tom. We're declaring the variable, but we're not actually doing anything with it. Okay, so here we've got a variable, but if I was going to try and use this variable later on or read from it, well, it's going to fail, right? So that's a problem. So so there's two steps. There's declaration and there's also initialization, right? Variable initialization is like player score is 100, like what it says here. And you're going to see that these two marks that come up in my program, and they're like, hey, you know what? My code hinting is telling me I can probably put these things together, right? There's use cases for both. Sometimes I want to keep them separate, and sometimes I want to put them together. But you could do it in one, and I'll show you what that looks like when you join declaration and initialization together as one. This is where I'm both declare and initialize a variable. That's how it works. Okay, if I declare and initialize it on one line. Positive about this, saves lines, and if you can do this and there's nothing that is going to affect it, if there's no side effects, this is okay. Sometimes this is not possible, and it's not possible because maybe I want to wait to do something to it before I initialize it. Okay, so that's possible. Sometimes we need to declare something or initialize it with a value of 0, right? And by the way, do I have to do this in C++? In fact, do I even have to initialize at all in C++? What if I was to try and do no initialization? So I didn't use, kind of use it, and I want to output this to my output stream. So I want to say the player score. Let's try this together, guys. And here's your challenge. I want you to, on your own, I want you to figure out how to output this to the stream. Now, here's something I want to tell you, that there is no there's a bunch of ways to do this, okay? But I want you to see if you know it from a language specific. If you've been using C# from before, see if the C# way works out for you and that it works, right? But see what happens if you try to output player score. So I want to say something like player score is like this. Let's try this out. Player score is a space, and then I want to output the player score, okay? So how would you do that? The player score should be here somewhere. So if I just kind of do this right now, run the code, does it even run is my question. And the answer is it does. Even though C++ didn't initialize anything here, it still ran. It didn't, not compile or break the code or anything like that, right? So it did compile. Okay, cool. So how do we do it? What do we do here? Anyone have some suggestions? Player score. Yep, you could do that, but I want a player score and then the actual string plus something else on the side. Player score toString. Well, player score toString doesn't exist that way exactly, but we'll get to toString in a bit, right? So you could try it this way. So here's one. I could do something that looks like this, player score, right? So I could do that, and it's giving me some suggestions, but I wanted to show you this for a second because take a look. I have my input stream or my output stream. That's what this is. That's the output stream operator. I have another one over here, and then I take these two together and I'm combining these two streams. So how does that work? Well, let's go back to my annotation, which is kind of neat in C++. This one kind of adds on to this one, and then this one kind of outputs everything to here. That's how it kind of works, almost like a waterfall, right, of streams, right? That's how it kind of works. So that's kind of interesting. So I could do this, and it's giving me a warning, and the warning that I'm getting is, well, you haven't initialized anything, is what it's saying. It's like you're just going to get a value of 0, and that's a real issue. Is that what you want, is what it's telling me. So let's see if that works. If I kind of run this, and then I get an error that says there were build errors. Let's take a look at what the errors look like in C++. If I say no, it says uninitialized local variable player score used. Now, question for you. In C#, would this run? I mean, it ran before, right? It just ran, and then suddenly it's not running anymore. So what if you were going to try this thing in C#? Would it run? Some people say no. So it's interesting the way it works. It's declared, but it's not initialized, right? Well, in Java, this would definitely run. Okay, I'll tell you right now. And the reason why is because in Java, and even in JavaScript, if you're running with that kind of language, the default value for a variable that's declared as an integer is 0. Okay, that's the default value for an integer. But here, there is no default value. In C++, it doesn't assume anything, right? So because we haven't initialized it with any value, that's why it gives us an error. Now, if I was to initialize it, let's say, for example, I initialize it as a 0, if I can actually type 0 today, 0, right? And if I did this, and if I just ran it again, right, then you can see that it says player score is 0, and we're good, okay? So this is definitely one way of doing it, all right? Player score is 0. We initialize and declare on the same line, and that's okay. But what about, can I add them together? Like I know in other languages you might see situations like this, plus and then player score, right? You might see something like that. Will this do the same thing? All right, let's try this out. Well, no, not in C++, right? And the reason why this doesn't work is why. Why does this not work, right? It works in C++, C#. If you did this in C#, something like this, a console write line, it'd be fine, right? But not so in C#, in C++, I mean. Doesn't exactly explicitly cast a string. C# natively supports string, correct? So what if I did this? Would this fix the problem? If I kind of did one of these, put it in brackets, would this kind of fix our problem? You can see that the brackets are kind of grayed out too, by the way, if you try this out. And then look what it says. It even told me this. It says the above will not compile because the plus operator is not defined in the standard string. Right? Well, it actually tells you that. If I hover over, it says adding int to a string does not append to the string. It doesn't do that. All right? So it doesn't do that. And in C++, in C# or in other languages, even in Java or JavaScript, this would be fine, right? It understands how things go. But just like Jesse says, it doesn't explicitly cast this to a string. If I wanted to convert this into something that I can output with this operator, I'd have to convert this to string. And there is a function for that, but we need to include another library. Let's include another library here. So we'll say include, and I want to include string. Okay, that's the string library. So I got two libraries happening, and I want to include string. And the way you can do this, if you put in standard string, right, and I want to do kind of like a two-string. So a standard two-string. And in brackets, I can kind of convert this. I don't need this other extra bracket over here. If I can convert this to a string, and then concatenation is possible. This is the regular thing that you would normally expect that happens with C#. Here, you have to do an extra operation. Okay? If I press play now, you can see that I'm going to get the same thing I got before, which is 0. Okay, so that's two ways. I've shown you two ways, this way and then this way, right? The other way that I had it before, which is player score is, and then followed by the input operator or the stream operator, okay? By the way, this is pretty good to do, but standard end line, right? Here we don't have an end line, so I would have to do something like, well, I could kind of add that in at the end, right? I kind of add that in. So there's my inline character. Could do this because this is legal because this is a string, this is a string, and this is a string. Here, this is okay, but it doesn't recommend it, right? It's just adding an end line, and if you see how it fixes it, it'll just do exactly that. Okay, single quotes, double quotes. Do I need to use one or the other in C++? Well, for control characters like this, right? This counts as one character. That's what this counts as, an escape sequence. So then certainly you can use single quotes. But if you use single quotes other places, it considers it a character, right? And if it's a character, characters are different than strings. So example would be if I tried to add in something else, like for example, I don't know, B. Let's say I said, I don't know, character B, like this. What would happen here in the second thing? You might get some weird side effects. Let's take a look. And if you run it, it says 0B. It kind of worked, but you can see that one kind of made our line go to the next line. That's what the \n did. If I didn't include this, right, and if I kind of did something like I just did earlier, and if I run it again, now you're going to see that it's all on one line, right? And why? Without the \n that you explicitly must put in, or standard end line, this cout is like a console.write if you're doing C#. Okay, that's what this is. Standard two-string not working. You need to include the string library. If you don't include string, then it won't work. Okay, so standard two-string allows us to convert something to a string. Okay, otherwise you can't do it. All right, good. So we've done some concatenation. We've done some other things with variables, and we know that this is doable. Let's put in \n again, right? And we can also do this as well. We can also say plus, \n. All right, we can do kind of double quotes or single quotes. Both are viable, right? But notice it says adding int to a string, right, does not append to the string. So this doesn't append to the string, but somehow it worked before. If I do this now, what will happen? And if I run it again, you can see that it gives me 0, right? But meanwhile, it gave me something before. If I took this away, right, and let's say I put in this standard end line, right, and take away the semicolon here just to make sure it's one statement, don't need two semicolons, this will work, right? This will work. You can see those, I get the same result there, but I don't get the same result when I do plus. I can't do this. I can't do plus, right? Because, or even a single quote like this for the same reasons that I did before. Well, actually this, if I was going to do that, you can see will not give me anything, but will actually give me the character 10. Okay, that's interesting. So what the heck is this? Why am I getting 10 for my player score when, I've initialized it to 0? Anybody? Take a look. If I run this now the way I have it, here's the code. Here's the code. I'm getting 10, but I'm not getting a \n character, and then I'm getting this. Why am I getting this? How come that's happening? Anybody? The default value? There's no default value for player score, right? So that's not what I'm getting. Why am I getting 10? I'm getting this. This is my output. Yes. So Gavin's got the right answer. \n is ASCII code 10. Well, 13 actually. But anyways, it's giving me a value. It's trying to figure out what this thing is. Let's try this out. If I was just to output, if I was going to try and output this, so let's say I don't do this, and I just output this just by itself, this. And if I run this, what do I get? Well, I get actually nothing. Everything is good, right? But let me undo again. But what it's trying to do with the plus operator, it's trying to give me, look what it's telling me. If I hover over my plus operator, it's actually doing a plus operation. It's taking my integer, which is player score, and my character, which is \n, and trying to add them together, right? And what it's actually doing is it's coming up with its own value for \n. \n is not 10, it's actually 13. But it's, you know, that's what it does, all right? So it's kind of weird. So please don't do this when it comes to everything else. You'd have to do standard plus this, although this would totally work. If I use the stream operator every single time, it's going to be fine. So this is okay, but mixing streams and concatenation, unless you do it a different way like this, is not fine. Okay, let's try this other, one more thing. I converted this to a string. I added it to this string, so I can do string concatenation. Can I also stream on this side? How about this? That's the ASCII value. There we go. Can I also stream on this side? Is that going to be okay? What do you think? If I was going to compile this one, does it compile? I know I'm going a little bit crazy with this, but there's a reason for this all. So if I run this thing, well, you're going to see it still compiles, right? So how can this compile when I'm concatenating these two things, but when I add them together up here, it didn't work? How come? Well, the reason for this is pretty simple. It's because this is a string, and so is this. These are two strings. So what happens is these two strings combine into one string together. Here's the string that it combines to. And then it's just like saying, here's my stream operator, which basically sends it to the console, and it takes this \n character, which is the new line character, and sends this along. So this \n character adds to this string, and then it takes from this string and it goes to the console. So that's how it works. It's okay. It does link things of the same type, but remember that if I was going to add in two, you know, kind of values, then different kinds of values, it might be weird. Okay, so this is kind of one thing we have to talk about. Let me just clear this up here. Are we good? Are we understanding? And the reason why I'm saying these things, guys, is because this is the very basics. Okay. So I want to use this one. I don't need this one anymore. We're graduating. We understand how this works. We also know that declaring and initializing a variable is what's happening here for player score. So we don't need that comment anymore. And I want to initialize my player score to 0, but I want to add, you know, my new score that's incoming. All right. So let's say, for example, I have a new score, int new score. And let's say my new score value, or we'll call it score value. How about that? Score value, or score amount, or something like that. Let's say it's 100. Okay, there it is. And I want to take my player score and add it to my score value. Question: when I read my player score, do I change it? Do I change my player score when I'm reading from it? Like, so I'm trying to add these things together. That's good. If you said no, it's correct. Some people have this idea that if I read from this, then I'm changing it somehow. It doesn't change. It only changes when you write something to it, and the only time that you're writing anything to it is when you're assigning something using the assignment operator, this thing right here. Okay. So I want to add these two things together. So naturally, I'd probably do something like player score is equal to player score plus score value. What if I just said this? Is this what I want? Player score is equal to score value. I mean, this would set it. This score value is what I want. That's a 0. I'm adding it on, right? So realistically, I'm just taking this value that's stored in this box. And again, if we think about variables just for a second, and I know this is like weird to think about, but if you think about a variable as a box, so if I have my initial score value is 0, right? So that's like, this variable right here, right? And then I have another box over here, and this one is worth 100, right? Sorry, I'm drawing with my mouse, right? But here's 100. And now I'm saying, well, I want to take this one and put it into that one. Take this value I'm reading from this one, and as I'm reading from it, I'm kind of filling this box up with 100. That's what I'm doing. So the assignment operator, it does this. It takes the value from here, this memory location, and basically assigns it, basically refills this memory location with whatever in the other side of the equation. So it takes this value here as an example, which is score value. That's this value right here, right? And then it takes it and then it assigns it to player score. So whatever was in player score before is wiped out, so it's not 0 anymore, and becomes 100. That's what it comes. Okay, so this is kind of the thing to think about when we're doing the next part. So, okay, now, what if I had my initial player score was 10, and I want to add my player score, my score value to it? What's the way to do that? So I have 10, and I'm adding, my player score to my score value. I'm doing some basic math. How do I do that? Okay, so some people wrote plus equals. Well, let's do the basics. So the basic is player score is equal to player score plus score value. This is a long way of doing it. So why does this work? First of all, let's try it out. And we should have 110 if I press it out, kind of output. The output should be 110. Computers are great with math, right? So they can do this kind of calculation very simply. But why this? Why do we have to do this? Just the base. This is the basics of what we're doing. Well, the shortcut, there's a shortcut, but why this? I mean, it's like I'm repeating myself. I'm saying, hey, play score, I want you to take play score, but that's kind of what, it's already 10, and then I don't understand. Well, you got to break down your thinking a little bit. That's the answer, right? So imagine if, I'm just going to annotate this again, right? We're saying, I want to equate this. I want to use the equals operator. Well, the equals operator, think about it as a function, right? And now I have two parameters. I have, one parameter here, and I have another parameter here, let's suppose, right? If they were separate, and I was doing something with those two functions, but the equals operator is basically saying, take these two things, or whatever's on this side here, and assign it this whole value, whatever this is going to be, and just replace whatever's inside player score with this stuff, whatever's on the right-hand side. That's what's me really doing, right? So that's what I want to do. Okay, that's what I want to do. But here's something. We know that player score is already equal to 10. Okay, that's what player score is equal. And we know that score value is equal to 100. Okay, so this is something to already to see. So I got 10. I want you to see this as like player score is a stand-in for this value, whatever the value it's holding. And score value is a stand-in for whatever this value is, right? So it's standing, it's a placeholder, if you will. Right? That's what a variable is in many ways, right? So when I want to reassign, I want to add these two things together, what I'm really saying is take whatever is in player score already, which is 10, I don't want to lose that value, and assign it, add it, the add operator, I'm using the addition operator, add it to 100, right? And then once I've added these two things to 100 together, then assign it afterwards. So this is first, this happens first, and this happens second, all right? So this is something that has to happen. This is the equals operator. The equals operator happens after I do all this stuff on the right-hand side. So why is this really pertinent to you? Order of operations, my friends. When we do things with math, with a computer, one thing to realize is that anything that happens on the right side of the equals happens before the equals runs. This always runs later. Okay, we do all this stuff first on the right-hand side. So if I was just going to say, like we had before, if I just wipe out player score, and if I just say player score is equal to score value, well, that's just going to equal to 100, right? But I want to add them together, right? I don't want that. Instead, what I want is I want to take whatever this value is, resolve it. So player score, the compiler goes through and goes to this line here, line 10, and goes, what is he trying to do here? What's Tom trying to do here? Oh, Player score. Well, what does player score resolve to? That means if I just have the variable here, it means look inside the variable. What's the value? Well, that value is 10. Okay, so that's what I need to get there. Okay, go into score value, get the value that's inside of score value. Well, that value is 100. Now let's do the add operation. The add operation has two parameters. It has 10 and it has 100. Add these two things together, and now it's going to resolve. The result is going to be 110. That's what it's going to do. And 110 is going to be on the right side of the equation, and it's going to take that and then do step number 2, which is assign it to player score. Right? And I know this is going really, really slow, and my hands are like this because I hope you understand how this works. And if you didn't think of it before, what it's doing, that's why we're having this little workshop, to really explain how this is happening, right? Especially in C++. This is all memory location stuff, okay? Let's wipe this away. So this is good, but someone recommended a different way of doing things. So this clearly works because when we ran it, it's okay, right? It runs and we see the player score is 110. But now what I want to do is I want to make this faster. I'm repeating myself. And again, we want to use less repetition as possible. So what's a fast way of doing this? As someone mentioned earlier, there's something called the compound operation that we can do, or the shortcut operator. And there's many shortcut operators. This is one of them, plus equals. This is like saying, player score is equal to player score plus score value. It's the same thing, but we're doing it in a very, very succinct way of looking at this. Now, I'll tell you something. This is new, but in some languages, they don't support this at all, okay? C++ supports it, C# supports it, C, Java supports it, Kotlin supports it. Lots of languages, modern languages support it, but Swift does not support this, okay? The Swift language made by Apple doesn't want you to do this at all, actually, okay? So, and there's reasons for this, because sometimes people don't understand what this really means, okay? So this is an issue, okay? This is an issue. So that's something that we want to use. I personally like using the shortcut operator. It's kind of solves some problems for me. It makes it a little quicker, right? But the plus equals operator only works when you have a succinct value on the other side and you want to just add one thing. Sometimes you can add multiple things here, then it adds it to the original one, and that maybe is not what you want, right? So please be careful. Sometimes the plus equals operator can be the cause of bugs, right? Because I'm taking whatever I have on the right side and adding it onto the original value what I had in my player score, right? That's what this operator means. It's convenient, but it can cause bugs. So be careful. All right, so this is very good. I like this. And of course, there's also the minus equal operator. There's also the times equal operator and the divide equals operator for all this stuff. It kind of works out the exact same way. And there's also the percent equals operator as well. What's percent used for? Yeah, percent equals.
Modulo, it's the remainder.
Modulus, yeah, it takes the remainder. And this is really great, for me figuring out some values, right? If I want to figure some things out with math. So the percent operator allows me to do that, and we'll talk about that later. But for now, this is pretty good. And if I do this and if I run it, like I said, it works just like it did the last time. We got 110. I know I'm going super slow, guys. I know some of you are really bored already. We've been an hour and 10 minutes, and we just did adding the two variables. But I'm telling you, this is the cause for consternation among our programmers in our little community, where they don't understand just the basics about how this works. Okay. All right, this is neat, but I want to talk about something else. What about, can I declare these two things on the same line? Like I want to do player score and score value. I want to do this, right? And then I want to assign these later. This is a shortcut. I can definitely do this. I can assign, a bunch of these things. Is there another way of doing this in C++? Is there another way? You can see that I got all these underlines here. Right. Well, in C# actually allows you to do, multiple assignments on one line, believe it or not. It's a real shortcut. But it says that if I go, it says join declaration and assignment, and it's trying to get me away from doing that thing altogether. It's telling me to go here, right? So what I can't do is this. I cannot do this. I can't say, well, this is equal to 0, right? And this is equal to this, right? I can't do this, right? This is not legal, is it? Can I do this? So Matthew says it shouldn't be, you know, and let's see what happens when I do this. If I press play, do I get an error or does it build? Well, now this is interesting. All right. So player score is 100. What the hell? How did I get player score is 100 when I said like player score is plus equal to score value? I don't understand. What's going on there? How come I got 100? What happened to my original player score now, right? Let me show you that again. Okay, this is like a real weird, tricky side effect. Player score is 100. What happened to my original player score? Why isn't it being calculated here altogether? Anybody have an idea? Well, if player score, okay, player score is 0. Let's put in 10. Let's see if that works. Good, good. Let me try again. All right, so let's try. Hey, look, there's 110. It works. All right, but what was the error in my thinking? When I redid this, I restructured everything, and there's a bug, right? I kind of went through and I'm like, I added it, and then I didn't, you know, how am I going to debug that? It's more difficult, right? So even though you can do this, you can totally do this, right? And you can do a line like this in C. The question is, should you do this, right? What are you saving? A line of code? My answer to you guys is, please don't do this. All right. Yes, you can. You can totally do this, but I recommend this as it is much clearer. It doesn't help in any way for the CPU. We talked about this in our class, right? We talked about one thing we discussed in our class was big O notation. We did data structures together. And one thing we said in data structures is that assigning something is O of 1, which means it's like literally there's zero, you know, overhead for assigning stuff. Assigning stuff takes nothing, no value, right? And so if you think you're saving anything by putting everything on one line, please don't do it, right? It doesn't save anything. It doesn't do nothing for performance at all, okay? And it's also ugly, like we just said. So here's a comment. So here's I'm declaring variables for my game. Here it is, right? And I got player score and score value. I don't know if that's such a great comment, right? But you know, here it is. I'm adding this thing together. I'm getting my score value, adding together. And if I run it, right, then I'm good. I'm okay right now. What if I wanted to add together other types? So we have a few types, and I want to talk about the types that we have so far. So we talked about variables here. I talked about the three things: the value that has to go inside the box, the name of the variable, and the type. Those are the three things that you need every single time that you have a variable, right? And I talked about these things, the first step, the second step, and so on. I want to get input, and I want to get input from the player. So the player or the user is going to give me some input. So I have my original player score, and I want to get my score value from my user now, right? And the hint is, here's the challenge for you guys, right? And we'll take a short break after this. But the challenge is I want to get input, and I want to use the standard input operator from my console. This is the challenge. And I want to save the input inside my score value. And then I want to add the score value to my player score and then output it again, which is my final score. Okay, so I have my original player score. I have an input from my player and then, or my user, and then I want to output, you know, those two things together. Challenge for you guys. How do you do it? And, you know, can you get it done? Please don't look up anything like ChatGPT or anything else like that, please. I prefer that. Is a bad thing, right? So, you know. Anybody? You have a challenge in writing? Sure. Here's the challenge, okay? So here's the challenge that I want you to do, and we'll leave you with this. We'll take a short break right now. How about that? So here's the challenge. All right, so the challenge is, we'll use this kind of stuff. So get input from the user, right? And then using the standard CN, right? That's what we want. That's the challenge. And then what I want to do is, you know, assign the value from the input to score value. then add the score value to player score, and then print the player score to the console with a nice message. Okay, that's what the challenge is for you guys to do. And how could I have written this differently? How could I have written this differently? Well, I could have done this. And I could have written it as multi-line comments. Be careful about multi-line comments because one thing that happens is it also makes my curly brace a comment as well. But I could do this multi-line comments. This is my challenge to you guys. Let's see if you guys can handle it. It's not a big challenge, right? I got 2 does. There we go. All right, and we'll take a short break. And when I come back, I want to see what your solution is. Okay, this is the first challenge we're going to have. We're going to have maybe another couple challenges today before we end for the day. Okay, so I'll take a short break and I'll stop recording this when I am streaming it on YouTube. I'll stop recording this as well, and then when we get back, we'll fix the challenge.